Hello. So today what we're going to do is we're going to start talking about angle relationships, right? We're going to start that off with adjacent and vertical angles. So as we kind of mentioned a little bit in our first unit, right, we're going to be talking about, different types of angles and their properties, and we're going to be able to use that to find missing angle measures. So the first thing that we're going to do, we're going to talk about adjacent angles. So adjacent angles are two angles that are next to each other. Right, that's what adjacent means. So they're next to each other and have a shared side on the interior of the two angles, right? So when we're talking about interior and exterior, right, a lot of times what we're doing is we're talking about, the smaller side of things. So in this case, right, if I'm looking at this little diagram I've got over to the left here, if I'm talking about angle COA, right, something like that, I'm generally talking about this angle that goes where that little blue marker is, right? We generally don't talk about COA as this big angle out on the other side, right? That's kind of referred to as an exterior, right? So if they share a side on the interior of the two angles, then we would say they're adjacent, right? Sometimes you can kind of mess around with that part a little bit, but for the most part, that's what we're going to be talking about. So to figure out if these things are adjacent or not, right, you just got to take a look at where they are and say, all right, do they seem to be next to each other? So first part is angles G and E, right? So if I'm looking at those two angles, they're not even close to being next to each other, right? So we're going to say no there, right? So that one's pretty easy, right? If you were talking about E and F, you could maybe do that, but G and E, definitely not. On part B, right, if you're talking about angles 7 and 8, right, 7 over there, 8 over there with a double, right, this is one where it could be a little bit tricky, right? You could say that they are adjacent, right, because, they are next to each other, but the key part is that middle side, right, this ZY piece is not on the interior of the big angle they all make together, right? So in this case, we would also end up having to say, no, they are not adjacent, right? So that's where it can get a little bit tricky, right? Is that, it needs to be on the interior. When we're talking about an angle bisector, right? This one's not too bad. As you can kind of see, right, we've got this diagram where we've got this, this big angle QVP, and then it's kind of split in half by VR. That middle piece there is at 62 degrees on either side. The formal definition for an angle bisector is just that it's a ray, right? Like VR in this case, right? It's got a starting point and a direction. It's going from V in the direction of R. It's a ray that splits an angle in half. Right? And the in half part is kind of, where the name bisector comes from, right? Bi means two, so sect means to kind of like break up. So bisector, splitting it into two equal pieces, right? The way we would describe it here, like with proper notation and everything, is we would say that the ray VR, right, with that little arrow, like showing the direction, VR bisects angle QVP, right? Because it's splitting that big angle in half, right? It's the same on either side. So normally what we would do is we would, go through a whole construction of bisecting an angle, but seeing how things are right now, it's not really an option. So what we're going to do is we're just going to keep on moving along, which is A-okay. We have this thing called the angle measure postulate, right? And in geometry especially, we're going to run into these things called postulates and theorems. There are also things called lemmas that you could run into way in the future, right? But what they are is they are things that we, are saying will work out, right? That's going to help us out when we get to talking about proofs, which is coming up later this trimester, right? So we use postulates and theorems to kind of, bank things that we can definitely say for sure and, say them a little bit more succinctly, right? So instead of saying, if BVC and CVA are blank, then blah, 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 you would just say angle measure postulate. Cool, done. Right? So in this diagram, right, we're talking about these two different angles, right? So if angle BVC, right, this one right over here with the yellow, and angle CVA, which I'm going to fill in with blue, are blank, then when you add them, right, when you add the measure of BVC to the measure of CVA, it equals the measure of the big angle, right? So the missing word there is adjacent, right? So if those two angles are adjacent, right, if you add that yellow piece and that blue piece in terms of, what their actual measures are, then their entire measure will equal out to the big one, right? You can see that that purple piece or pink or whatever, what color you want to call it, is just as big as the yellow angle plus the blue angle, right? So that's what we're getting at, is if you have two adjacent angles like that and they are next to each other, then you can add their measures and it will equal the big angle that they make together, right? So we're going to use that, right? We're going to go ahead and try to figure out the measure of angle DAE, right? So what I would suggest doing, right, and this is maybe something that's easier to do with a pencil or something like that on your paper because it's not as easy to erase all the time. I'm going to do it on here with the highlighter just to really show what we're talking about. If I'm looking for the measure of angle DAE, right, I know the measures of two different little pieces in there, right? I know about that 35 and that 90 that kind of make it up, right, these two pieces. So all you need to do is just add those together. Right, so 35 degrees plus 90 degrees equals 125 degrees. And that's all we need to do for that, right? Same deal for these other ones, right? If I'm looking for the measure of angle EAB, right, this one can be a little bit tricky, right? So remember a little bit ago, it's talking about how when we're talking about angles, we're usually talking about the smaller piece of them, right? So when we're talking about EAB, we're not talking about this big piece along the outside, right? What we want is we want the measure of this smaller piece on the interior of it, right? So in order to figure that out for this one, it's a little bit weird, right? Because we don't know any of the markings, like we don't know any of part of that angle that we're looking at, right? Where that blue arc is. But we do know everything else. So something we haven't talked about quite yet is, you might know this from before. If you make like a complete spin, if you're familiar with like snowboarding or skateboarding, it's called 360. So there's 360 degrees as you spin all the way around something, right? So if I started down at E and I went all the way around just like that, I have traveled 360 degrees. So I know that it's 360 degrees the whole way around. So if I take 360 and then I subtract all those other pieces, the 104, the 35, and the 90, that's going to leave me with just that chunk I'm looking for. So 360 minus 104, and also minus 35, and also minus 90, right? If I take away all those pieces, might not be a bad idea to use a calculator, it's going to come out as 131 degrees for that piece over there, right? And that's all we're really doing, right? It's 360 all around. You take away all the other pieces, you end up with 131, right? Last but not least, we're looking at angle BAC, right? That one right there. And again, we're looking for this interior piece. And for this one, it's a little bit easier. I know what those two pieces are. We've got a 104 and we've got a 35. So if I just add them together, that's going to give me 139 degrees. That's what I'm looking for here, right? If you're looking at this page and you're like, oh my God, there's so much stuff going on, what I might suggest is put a little box around your final answer. Sometimes it's a little bit nicer or a little bit easier to keep track of what you're doing if it's all boxed up when you get your answer for each of these, right? Feel free to do whatever you want, whatever makes your life easier, I guess, as long as it's still correct. So what I'd like you guys to do is pause here. If you want to pause while this one's still on the screen, you can do that. But I want you to try out number 3. It's pretty darn similar. All right, so hopefully you paused and tried that out. If not, try it. Give it a go. Give it a go. It's not that bad. All right? We're going to talk through it together real quick. So we've got GKL, that piece right there. So we're going to do 50 plus 90, which is 140 degrees. All right. When we're moving on to the next one, right, we've got JKL, right? And again, We're talking about this piece on the other side, not the big wide piece on the other end. Right? So if I take 360 and I subtract the 60 and then I subtract the 50 and then I subtract the 90, that's going to give me what's left over on the other piece, right? And all together, that should be, I believe, 160 degrees. Right? For that last one, JKI, right, we're looking right over there. It's made up of those two pieces there. 60 plus another 50 is going to give us 110 degrees, right? And that's all we need to do, right? We're just adding up these different pieces. Sometimes you're subtracting them from 360, right? But all together, that's what we're working on. All right, so adjacent angles and adding angles hopefully seems pretty all right. We're going to talk about special types of sums that you can get with these angles. So when we're talking about complementary and supplementary angles, I find that these are actually some of the hardest ones to remember which one's which, because they're, as you can tell, their definitions are pretty similar. The only difference is going to be that fill in the blank piece. So when you have complementary angles, they are two angles that sum to give you 90 degrees, right? When you're talking about supplementary angles, they are two angles that sum to 180 degrees, right? So like I said, a little bit hard to keep track of which one's which sometimes. So here's the trick that I use. If you think about the words complementary and supplementary, one starts with C and the other one starts with S. If you're thinking alphabetically, C comes before S, 90 degrees comes before 180 degrees. That's how I think about it, right? So the earlier one, complementary, is 90 because it's smaller. The later one, supplementary, is 180 because it comes later, right? So that's how I try and keep track of them. If you need to keep flipping back to this to figure out which one's which, that's okay, right? It is a little tricky. So we're going to do a couple examples of these. So if we assume that the measure of angle A is 43 degrees, I want to figure out the measure of the complement of A. So if I'm looking for the complement, then that means that they need to add to 90 degrees, right? So what I'm really doing is I'm asking myself, all right, how much further do I need to get from 43 up to 90? All right, and one way that I can do that is I can just start with 90, take away the piece I know, which is 43, and 90 minus 43 leaves me with 47 degrees, right? And that's all we're doing, right? We're just kind of running through it just like that, trying to figure out, all right, what's the piece that gets me the rest of the way there, all right? Same kind of idea for number 5. We're going to assume that the measure of angle B is 74 degrees. I want to figure out what the supplement of B is. All right, again, supplement means that they need to add up to 180. So again, same kind of idea. You can start with 180 and take away 74, right? So you're taking 180, you're taking away the piece you know, and the piece that's left over that you need to get there is 106 degrees, right? So hopefully it doesn't seem super duper bad. Right, excuse me while I hydrate real quick. Lots of recording today. All right, so some of these questions can get a little trickier. All right, so we're going to talk through this one together, and then we're going to kind of split into two different paths because we got an honors class and a non-honors class. So we'll talk through this one all together. So stick with me for now. So for number 6, suppose that the measure of angle A is x plus 10, and the measure of angle B is 6x plus 30. If A and B are supplementary, what are the measures of those two angles? All right, so the way that we would handle this, right, is that I know that A and B are supplementary, right, which means that when I smush them together, they equal 180. So if they need to equal 180 when I add them together, I'm just going to add them together and have it equal 180, right? So the measure of angle A is x plus 10, and then I'm going to add on angle B, which is 6x plus 30, right? And again, I'm literally just adding all of it together. They're supplementary, so that I know equals 180 degrees, right? So once I have that, it's just a big equation, right? It just turns into an algebra problem, actually, right? So from here, what I'm going to do is I have some like terms that I can combine on this side. I have an x and a 6x. I have a 10 and a 30 that can all smush together. So the x's all together will give us, oops, that was kind of weird. Let's try that again. The x's, when I smush them all together, will give me 7x. The numbers, when I smush them together, will give me 40. So you get that 7x plus 40 equals 180. After that, I need to get rid of the 40, right? Get that away from where my x's are. And so I'll get 7x equals 140. And last but not least, for this part, I need to get that x all by itself. So I'm going to divide by 7 to help me get rid of that. And my x is going to be equal to 20. Right? So now that I know that x is 20, right, we're not done quite yet because we want to figure out what the measures of the angles are. Right? So now the measure of angle A is x plus 10. So off to the side here, measure of angle A is equal to that x we just found, right? X was equal to 20, right? So it's x plus 10, which is going to give me 30 degrees, right? The measure of angle B was equal to 6x plus 30. So 6 times that x plus 30. All right, 6 times 20 is 120. Plus another 30 gives you 150. With a little degree on there. All right, so measure of angle A was 30 degrees. Measure of angle B was 150 degrees. And that's what we're trying to get to. All right, so if I am able to use YouTube very well, then if you are in a non-honors class, click the little skip ahead thing that hopefully is showing up right now. If not, then I'll try and have it like show what the timestamp to skip to is and all that. If you're in an honors class, stick with me. We're going to talk through a couple more that are kind of like this, right? So what we're going to do here, right? There's a couple more of these. What I'd like you guys to do for this one is try this on your own, right? It's a little bit different. It's talking about two angles that are complementary. But the only difference there is that means that they just add to 90 degrees instead of 180, right? Everything else about the problem is pretty similar, so give this a shot. So hopefully you paused and gave it a go, right? Let's see how this works out. So measure of angle A is 7x plus 25. On top of that, I'm adding on angle B, which is 2x plus 47. And because they're complementary, I know that it all comes out to be 90 degrees together, right? So, same thing as the last one. I got some like terms that I can smush together. All right, just color coding there. So we got 9x, 25 plus 47 is going to give me 72. And equals 90 on the other side still. We ditch that 72 over to the other side. All right, and as we do that, I realize I should have given myself a little more space, but that's okay. 90 minus 72 is going to leave us with 18. We'll divide by 9 to get that away from the x. And x is equal to 2. All right, so if x is equal to 2, that gives us enough info to be able to plug that back in and figure out those other two angle measures. So the measure of angle A, actually, before I start running out of space again, let me shrink this down a little bit. The measure of angle A is equal to 7x plus 25. So that's 7 times that 2 plus 25. So 7 times 2 is 14. 14 plus 25 is going to give me 39 degrees there. All right. As for the measure of angle B, same idea, right? It's 2x plus 47, so that's 2 times 2 plus 47. 2 times 2 is just 4. 4 plus 47 is going to give me 51 degrees. All right? And something we can do to make sure that, you know, our answer works out is they kind of check themselves, right? We need these to come out to equal 90 together. If you added 39 plus 51, you are going to find out that it does equal 90, right? Two more problems before we jump back into everything all together. Suppose you're given two angles, A and B, in which the measure of angle A is equal to the measure of angle B. If the measure of a complement of A is equal to 5x plus 20, and a complement of B is 3x plus 40, what's the measure of a supplement of B? Oy vey. So there's a lot going on in this problem. So a couple key pieces of information, right? We've got two angles, A and B, and the measures are equal, right? The measure of angle A equals the measure of angle B. If a complement of A is 5x plus 20, and a complement of B is 3x plus 40, we need to figure out the measure of a supplement of B, right? So ignore that last part for right now, right? The what is the measure of a supplement of B, right? We're going to hold off on that for a minute. We know that A and B are equal, which means that their complements should also be equal, right? If A and B are both 40 and we need to get to 90, then those complements both have to be 50, right? There's only one way to get from the same number up to 90. So I can do is I can say that those complements are equal. So we're going to have that 5x plus 20 is equal to 3x plus 40. All right, let's clean up that 5 in the front, make it look less like a 6. So I've got these two things that are equal to each other. What I'm going to do is I'm going to solve it out and get that x all by itself, right? And then we'll kind of talk about what our roadmap is from there after we get x. So to do that, I'm going to move all my x's to one side. Oops, why did I? I'm going to move all my x's to one side. My brain's a step ahead of my hand as I'm writing. All right, so we're going to get that 2x plus 20 equals 40. I'm going to subtract that 20 to get it away from where the x's are. We're going to get that 2x equals 20. And then we'll cut them both in half. All right, divide by 2 on both sides, and x is equal to 10. Right. So we know what x equals. And from here, what we need to do is, first off, scooch that a little over. Right. So we know that x is 10. What that allows us to do is now we can figure out what the complement of b is equal to, right? We know the complement of b is equal to 3x plus 40. So if I plug in that 10, then the complement of b is equal to 3 times that x plus 40. All right, so 3 times 10 is 30. 30 plus 40, oops. I wish it would stop doing that, sorry. 30 plus 40 will give us 70 there. Oops, and again, my brain is shutting down a little bit. Probably the last video for today. So the complement of B is 70 degrees. So if that's the complement, then we know that the measure of angle B itself is just however much it takes to get to 90 from there, right? So you can probably do it in your head, but if not, you know, the way we can always do is we know that we want to get to 90. We can take away the piece we know, which is 70. And that's going to leave us with 20 degrees. Right, so measure of angle B is 20. Last but not least, we need the supplement of angle B. Right? And the supplement is just how far it is to get to 180. So we can start with 180, take away the piece that we know, which is now angle B. And that means that our supplement that we need left over is 160 degrees. Right? So lots of different steps going on here, right? We had to set those two things equal, figure out what x was, figure out the complement, then figure out the actual angle, and then figure out the supplement, right? Multi-piece thing there, right? But hopefully each individual piece, right? Like, you know, working them all together, maybe a little hairy, but each individual piece hopefully doesn't seem that bad, right? It's solving some equations, plugging some numbers in, right? Doing a little bit of subtraction here and there, right? So what I'd like you to do, it might seem a little crazy, right? But give it a shot. Try out number 9. So pause here, give it a go, see how it is. So hopefully you pause there. And again, excuse me while I hydrate real quick. So hopefully you tried out number 9. Let's talk through it together, right? Same kind of idea, actually. Basically the same problem with different numbers. We have two angles, M and N, where their measures are equal, right? So they're the same angle. The measure of a complement of M is 18x plus 10. The measure of a complement of N is 8x plus 30. What's the measure of a supplement of M? So again, it's actually the same thing, right? We have these two complements for these two equally measured angles. So we can say that 18x plus 10 is equal to 8x plus 30, right? Then we're going to go through this pretty much the same way as we did before, right? I'm gonna move all my x's to one side. We're just solving this out for x. I get that 10x plus 10 equals 30. We'll move that 10 away from where our x's are. And so we get that 10x is equal to 20. We'll divide by 10 on each side to get that x all by itself, which equals 2. Right, so x is equal to 2. So then just like on the last one, right, that opens up the ability to figure out what the complement is, right? We're looking for the measure of a supplement of m, right? So what I'm going to do is I can figure out the complement of m. So the measure of a complement of angle m is equal to 18x plus 10. So in this case, that's 18 times that 2 we found plus 10. So 18 times 2 is 36. 36 plus 10 more is 46. So if I'm looking for the measure of angle M itself, right, and actually I should probably use capital letters here. If I'm looking for the measure of angle M itself, right, it's just however much further we need to get to 90, because its complement is 46. Right, so 90 minus the piece we know, which is 46, leaves us with 44 degrees. That's the measure of angle M itself. Last but not least, we need the supplement of angle M. Right? That's just how far it is to get from M up to 180. So we take 180, take away the piece we know. 180 minus 44 should bring us to 136 degrees. And that's what we want to get to at the end. Right. So I'm going to tell you, these problems don't come up super duper often, but when they do, it's a good thing to be able to kind of work through them and relate all these different pieces of angles together, right? If you know a complement of an angle, you can figure out the angle itself, which will then let you figure out other things like the supplement, right? So, all back together now. We're going to talk a little bit more about a few different things, right? We've got a linear pair, right? So off to the side here, I've got a diagram that represents a linear pair, right? It's when you have two adjacent angles that sum up to be 180 degrees, right? So basically, linear, right? They make a line, and it's a pair. It's two angles. They are two angles that add up and make a straight line together, right? Like BVC and CVA in that diagram, right? Angles 1 and 2, they make a straight line when you put them next to each other. That also kind of leads us into this linear pair theorem, right? So like I mentioned, theorems are something that we might use a little bit later on when we talk about proofs. So a linear pair theorem is telling me that if two angles form a linear pair, then they are supplementary. Right? And if you're thinking like, well, that's what it means when they add to 180, right? You'd be right. Supplementary and summing to 180 are kind of saying the same thing, right? This piece here is that, right? So sometimes theorems don't necessarily say anything like new or profound about what we're doing. Sometimes they just say the same thing a little differently, right? But, that's not so bad because it's a little easier to remember, right? We've also got these things called vertical angles, right? So when we're talking about vertical angles, they are two angles across from each other at the intersection of two lines, right? So if I'm looking at this diagram over on the right where, mine are green, I know that yours are probably grayscale. If I'm looking at angles 1 and 3, those are vertical angles. If I'm looking at angles 2 and 4, those are also vertical from each other, right? So vertical is just across, right? If you want to think about it in a different way, right? If you look at 1 and 3 and you kind of tilt your head a little bit counterclockwise, they make two V's, right? There's one V for angle 1, a V for angle 3. And when those two V's are kind of touching each other like that, it makes you think of like vertical, right? We have the vertical angles theorem that kind of goes along with it. If two angles are vertical, then they have the same measure, right? So instead of calling it the same, you could call it equal, right? Obviously, those mean the same thing, right? They are equal statements to each other. So either one works, but if you have two vertical angles, they are across from each other and they have the same measure. All right, we're almost there. Ooh, so we have a transversal, right? A transversal is just a line that intersects two other lines, right? So in this diagram right here, the transversal is that line fancy L, which kind of looks like an E a little bit, right? But that's all transversal is, just crossing other lines. When we're talking about corresponding angles, this is another one that I find people have a little bit of trouble with, right? So make sure that you're listening up for this piece. When you have corresponding angles, they are angles that are in similar locations but at different intersections. All right, so if you're somebody from Bonnie Eagle that's watching this video, right, then you hopefully are familiar kind of with the intersection a little bit down from the school that has like the middle school sign, and then there's a little intersection further down where there's like a Walgreens and Plumber's Market and everything else. So we're talking about them being in the same location but at different intersections, right? The intersection that's close to the school has that sign with the date and the time and the temperature, right? It's on that part of that intersection. If you then go that little bit further down the road to where the Walgreens is, right? The corresponding part of that different intersection would be that bank that's over there, right? They're kind of in that same sort of location on their intersections, but they're at different intersections, right? If I'm looking at this diagram over here, and I'm looking at corresponding pairs of angles, if I looked at angle 4 over here, its corresponding angle is angle 8, right? Now, that doesn't mean that they are exactly the same necessarily, right? Until we talk about this next piece, right? But what that means is that they are both like in the bottom left of their intersections. If I looked at angles 1 and 5, those are in the top left of each of their intersections. 1 and 5 are corresponding, right? So you're looking for ones that are in the same like position in different intersections, right? So we've got this corresponding angles postulate, right? And this is a big one. This is something we're going to use quite a bit. So suppose two coplanar lines are cut by a transversal, right? So you just got two lines, they're cut by the same line all the way through, kind of like that diagram that's right up above. If the corresponding angles are equal to each other, right? Like if the blue ones matched up and the red ones matched up and they all equaled out, then the lines themselves are parallel. Right? Same thing, right? It just kind of said backwards. If the lines are parallel, right? Like if we knew that lines M and N up here, right, where we've got those, if we knew that those were parallel, then the corresponding angles are equal, right? So again, they say kind of the same thing, just kind of backwards from each other, and that's okay. Some of these postulates and theorems will do that, but it's good because then it works in either direction. So if I know that the lines are parallel, then those corresponding angles will be the same. But that's only if the lines are parallel, right? So be careful for that, right? Like the ones in that diagram up in the top right of the screen right now, those lines are not parallel. 1 and 5 aren't equal, and neither are 4 and 8, or 2 and 6, or 3 and 7. If they were parallel, then we could say that. Alrighty, excuse me. So we've got this figure here. We're going to assume that M is parallel to N, right? So that's an important piece here, right? So they tell us over there, they also show it on the diagram with these little parallel arrows, right? Remember that we talked a little bit about those when we were doing notation stuff, right? So what that means is that the corresponding angles are equal to each other. So if we wanted to list all the angles that have a measure of 85 degrees, right? If I'm looking at this 85 degree angle, I know that anything that's corresponding, like angle 8 down there, is going to be 85 degrees as well. All right, so we've got angle 8 would work. If I'm looking at anything else with the 85 degree one there, I know that it's vertical from angle 2, right? And we know that vertical angles should also be the same measure, right? So angle 8 and angle 2, right? Those are all 85 degrees. And then there's one more on there, right? So angle 6 has a couple different ways that we could get there. Angles 2 and 6 are corresponding, right? They're in the same part of their intersections, right? 8 and 6 are also vertical from each other, so they should be equal to each other that way too. All right, so we can actually say that 8, 2, and 6 are all 85 degrees. All right, then we got to figure out what are all the other angles going to be. So if I know that we've got 85 degrees over here, right, let's take a look and try to figure out what angle 1 is. Right? So if I've got 85 degrees in red and angle 1 is in blue there next to it, it seems like they make a straight line together, right? I'm going to use another color here. Sorry if it's too much. They make this straight line together when you put them next to each other. So that means that they have to add up to be 180, right? They have to make a straight line at 180 degrees, right? So if I take a solid 180 and I take away the piece I know, which is that 85 degrees, what that's going to leave me with is what the other angle is, right? Which is, in this case, going to be 95 degrees. So we know that angle 1 is 95, right? Might not be a bad idea. We can write that in there. All right, so actually, let me do a little bit more color coding, sorry. So I know that this 85 is the same as this, and this, and this. We know that this 95 degrees, right, by the same way, is going to be the same as 3 because they're vertical. 1 and 5 are the same because they're corresponding, and then 5 and 7 are vertical, right? So it all kind of matches up pretty nicely, right? We have all these different colors, and they all kind of match nicely. So last but not least, what angles are supplementary to angle 2? Right? So supplementary just means they have to add to 180. So angle 1 is supplementary because it makes a straight line with it. Angle 3, same thing. And then angles 5 and 7 are also the exact same measure, right? So every other angle that's, not 85 degrees, right, are all supplementary to 2, right? Let's try another one out. And by let's, I mean, give it a shot, right? It's kind of the same idea. And then this is it, and then we're done, right? So we're assuming that lines L and K are parallel to each other. Doesn't have that on the diagram, but if it helps you to put that on there, we can put those little parallel arrows. Right? All right, so let's go. So hopefully you paused and gave that a shot. Let's take a look and say which angles have a measure of 55 degrees. So we know that 55 degrees is right there, right? If I wanted to, work off the vertical angle piece, I know that 7 is vertical to it, so 7 should also be included there. After that, 55 is corresponding with angle 1 up top there, so 1 is included. And then 1 and 3 are vertical from each other, right? So I can also include 3. So 7, 1, and 3 all work and are all also 55 degrees, right? What are all the other angle measures? Right, so similar to the last one, right? We know that, 55 degree angle and angle 6 over there make a straight line. So you have to add up to 180. So if I take 180, I take away the 55 that I know about. Right, what that's going to do, that's going to leave me with the other piece, which in this case is 125 degrees. And then, again, which angles are supplementary to angle 7? Well, angle 6 is, because it makes a straight line with it. So is angle 8. Right? And then just like on the last one, every other angle should all be equal, either because they're corresponding or because they're vertical with angle 6. Right? So we can also include 2 and 4. All right, so I know that we just went through a whole lot of stuff here, right? If you have questions when I see you, please be sure to ask them. We can talk about this together. We can work through it, whatever we need to do. But as for now, I'm going to let you go because I've been talking long enough. So see you next time. Bye.